So here on page 477, we have 8.3 and we have the bubble sort. So this is the first of our two search mechanisms, and it is brute force. It will get the job done. It is, however, slightly inefficient. So what we're saying in a bubble sort is as follows. However many, so number one is however many elements you have in your array, it can take as many as number minus one sorts to get through and actually sort the elements in your array. So if I have 20 elements in my array, that means that the most number, so the highest number rather, of sorts that we will go through is 19. If I have 10 elements in my array, the most sorts that we will go through is 9. So it's always n minus 1. So again, if you think about a 10 element array or a 20 element array or a 500 element array, that's fast. If we're looking at a 500 million element array, when we are looking at big pieces of data, that is not particularly fast. So that's something to keep in mind. It is, however, accurate. So there is no question whether or not our two sorting mechanisms are going to work. They are going to work. It's just up to you which of the two of these you implement. So again, here on 477, you can see kind of how the bubble will work. What we elect to do is either sort our data in ascending or descending order. And what we get is at the end of every pass, the next greatest value will be either at the end or at the beginning of your array. So each pass we go through the elements of the array, what essentially it does is it either pushes to the back of your array the highest number, or it pushes to the front of your array the lowest number. And then the next pass, it's the next highest number or the next lowest number. That's why we get the idea of number minus 1, because each time we go through, we are getting one closer to having everything sorted out the way it goes. So what happens here, and what I've done is it should be above this video, I believe. You will see just a little GIF, essentially, of a bubble sort. What happens each time we loop through, what we do is we compare two of the elements in the array to each other. So we start with 0 and we compare it to 1. If we are looking to get things in ascending order, so from least to greatest, let's say 0 has the number 1 in it and element number 1 has the number 0 in it. So we would compare element 0 to element 1 on our first pass through, and we would go, okay, is element 1 greater than element 0? If yes, what happens is as follows. We need a third variable, a swap variable. So what we do is we take the larger of our two elements, excuse me, which is 1, and we preserve that value by assigning it into swap. We then write the value of 0 into 1, and then we write the value of swap into 0. So that's why it's called a bubble, because it's on the bubble and we're moving this bubble around. There's always a physical analog to how these work, and that's what the physical analog happens to be. So then we go and we check element 1 and element 2, and we do the same thing. When we're done with that, we go to 3 and 4, and we do the same thing. We go to 4 and 5, and we do the same thing. And I know what you're thinking to yourself is, I'm looking up above this video at that GIF running, and there are 10 elements in that array. And yeah, it's moving numbers. So it's moving the largest number all the way over to the largest element in the array. It's moving our smallest number potentially all the way down to the smallest element in our array. But man, that's taking some time, right? Yeah, that's what I said at the outset here is, the brute force method here for the bubble sort is complete, but it is inefficient. That's why we have potentially a more, efficient method to be able to do this, and that is the selection sort, which we'll see next.